All right, so this is day 2 of 1.5. There's not much left, so we'll try and work some problems out together so you kind of know what you're doing, that you're not always guessing. Here is a function on the board. Now, this would, to me, be a piecewise function, which we haven't even talked about. It will come next week, Monday. But piecewise functions are just pieces of functions. In this case, a line, a different line. Another line, another line, another line. Okay, so a bunch of lines, line segments. Okay, when you look at this, you have to understand, this is where we're going. We're going with average rate of change. An average rate of change simply means, the word rate means comparing units. And if you're going to compare units, let's compare different units, like miles per hour. Would that be a rate? Yeah. Miles per hour, dollars per pound, stuff like that, those are rates. Well, the average rate of change is what we're looking at today. So if I said in over time, does the average rate of change, does it change on this? Like for instance, like if this was how fast something went up, is that different than this speed? Yeah, this is going to be a little faster, then this is going to be a little slower. But here's the deal. When it comes to miles per hour, I need you to kind of understand, that sounds like something you've done before, right? Yeah. What? Okay, there you go. Because if I said you guys could go out and run right now, 10 miles per hour, do you understand? Do you get a visual of that? I can run what? 10 miles per 1 hour. Yeah, so for every 1 hour I run, I rise 10. I run 10 miles. So another hour goes by. I run another 10. But you know you can't really do that consistently. You slow down as time goes. Rate of change will change. Your speed changes. So here the speed between here and here could be, let's just say a slope, like 3. What would you say that slope is? 0.5. Half, okay. Then all of a sudden you started sprinting. Now the slope would be 5, maybe. Here you're almost walking. 0.1. 0.1 is your slope. Okay, here you're kind of half speed. Maybe it's a 2. So rate of change is really just what? Slope. That's all it is. Okay? So your job today is to calculate the rate of change. Okay, and it changes all the time. I might want to put M here for you because then you'll know what I'm talking about. Okay, yeah.
Can we just take the averages of the slopes?
No, because I'll show you in a second here. Here's the average rate of change. Now, if you look at this, guys, this is a curve going down and up. Okay, think of your speed in the car. You're driving a car. And right about here, you see this thing called what? A stop sign, okay? So, here's you. Now, the speed of your car is, here you are. What are you doing right now? You're slowing down. And you know you're supposed to stop, right? But did you ever hit 0? No, so you look, and you kept going, right? No, just stop. Now, so here's the deal. Your speed at any point in time is a number. It could be 7 miles per hour. It could be 20 miles per hour. But average rate of change means this. I'm going to give you 2 points in time, and now give me the average. So if I said right here, you have a speed in your car, and then right here, you have another speed in your car. So what I want you to do is take those 2 points in time and find the what? Average. Now, it's just a line. That's all it is. They give it a name. They call it the secant. The line going through your 2 points in time is called the secant. And then, of course, they put a little m here for find the slope of the secant line. All right. Now, for you to find the slope, you need a point, right? Okay. Well, we got to talk about these points. Let's call this point right there. This x value, you don't know it. We're going to call it x1. Okay, that goes with that. This point, what x value goes with this one? X2. Okay, so now we have 2 x values that hit the secant line. I need you to tell me what's this point. And then what's this point? Okay, say again.
X1, Y1.
You're telling me this one is x1, and he says y1. And I know why he says that. He's just calling it x for the x coordinate, y for the y coordinate. But if I really want to get fancy, I don't have to put y1. I can put exactly how do you get the y value if you know the x. If you knew the x value is what?
You just plug it in.
Yeah, you plug it in. What do you plug it into?
Equation.
Yeah, the equation. There's another name for equation.
The
The function. You plug what into the function? F of x1. You plug the number, the x value in, and you get out the y value. So this must be x what? 2, comma, f of x2. Got it. Okay, so there you go, guys. That is your point and your point in times. And you know you're going kind of slow. Right here, you're going kind of slow. Now you're really going slow. And then you're speeding up. But all I want is the average rate of time, your average speed. All it is the slope. So how would you get the slope out of this and this?
You subtract that, or subtract
Yeah,
the y's.
subtract the y's, but that would be what? F of
X2.
x2 minus f of x1, got it.
Divide that by x2 minus x1.
And then divide that by what?
X2 minus x1.
Okay, x2 minus x1, good. And this becomes your formula for average rate of change. It's right here in this box, let me show you. And you basically came up with it by yourself. So I didn't, now you can kind of see it better. And that's exactly what I wrote. So if you ever want to know the average rate of change, now I'm doing miles per hour because you guys, that makes sense to you guys. So let's talk miles per hour. From here to here, notice the line goes up. Do you think it's a positive or negative? Yeah. So we're speeding up. On average, we're speeding up. But if the line would have went this way, whoa, sorry, didn't mean to do that. I'm not sure where it was. Right there. Okay. So if the line would have went this way, you know the average rate of change would be, on average, you're slowing down. So it would be negative. Your average rate of change would be negative. Okay. So now go to your book and try the first problem in that section. I gotta look at it again.
57.
No, it's further back. It's right here. So you guys are doing, in your assignment, you're doing what?
110.
No, it's back. 57, 96, 3 is. Okay, so you're gonna do 60, 69, 78. Okay. Why don't you do 78? Let's do 78 here.
7.
Help me remember this, because I don't. Okay. Plus 8? Okay. All right. So everybody, I don't care what the graph looks like, but in a way I kind of do. So what is this graph?
Quadratic.
And it's a what? Parabola. And is it going up or down?
Up.
Yeah, positive x squared, it's going to go up, right? Now, what happens is that the slope on this graph changes all the time. Here you're going 20 miles an hour, 15 miles an hour, 10, 5, 4, 3, 2, 1. Now you're climbing. So the average speed is different all the time. They tell you that they want the average rate of change when the x value is what? They give you two x values, 1 and 5. So somewhere around, I'm just going to make this up, around 1 and 5, you're getting 2 points like this. So you're trying to figure out your average speed. So this is the secant line that they talked about in your book. Just find the slope of the secant line. And you just need points is all you need. You should know, we just talked about it, it's just going to be f of x2 minus f of x1 over, what do we say?
X2 minus x1.
There you go. Hey, I gotta ask you, doesn't this just say the same thing slope says? This is the y value minus the y value over the x minus the x. It is. Now, you know when you say f of x2, that x2 is 5. So you'd go like this. What's the value of my function when x is 5 minus what's the value of my function when x is 1? And then, of course, the bottom is pretty easy. It's the x value minus the other x value. So the bottom is simple. It's the top that gives you problems. F of 5 is right here. Put it in. 5 squared. Take away 2 times 5
Over 4 is 4.
plus 8. So what is f of 5? 20 what?
3.
Okay, you are correct. It is 23. Okay, 23 minus, now do f of 1, here, here. So that'd be 1 squared minus 2 times 1 plus 8. That is what? 7? Okay. Over 4. 23 minus 7 is 16 over 4, which is 4. Now, if we had units, if we did have units and they were talking like, let's graph time and let's graph miles, time and miles, that's miles per hour. So, yeah.
So those points, those ones give you like.
Yeah. If you open your book, Will, you'll see it all. Well, that's the problem, Will. And Will, if you're not going to bring it, I told you what to do. Yeah, I did. I said take a picture with your phone, and you get ready the next day. You can't come here without a book, okay? All right. Good or not good? Good or not good? Okay. Now, guys, when I did this problem, did I know if the slope was positive or did I know if it was negative? Did I have any idea? No. I had no idea because I didn't really have the graph in front of me. I made up that graph. I don't know if it goes up or down until I do the work. But once I see the answer, I do know if I drew the line through the graph, it would have gone up. Okay, there's no way I can tell you if it's positive or negative until I do the work. Okay, unless you want to actually graph the function, plot the points on the graph, connect the points, then you'd know it was positive. It's not worth it to me. It's too much time. Okay, everybody good? Hands up if you're not. Move on. Okay, even odd, even odd. You know what? You've already done this. You did this in section 2. In section 2, we talked about symmetry of a graph. If a graph is symmetrical to the y-axis, x-axis, and origin. But the only thing is now they call it what? Even and odd functions. Now, even functions, basically they are symmetrical to the y-axis, okay? Where odd functions are going to be symmetrical to, it seems like it should be x, but it's not. Origin. This one is symmetrical to the origin. Now, here's the deal. You already did this, so it's not going to be that hard unless you just can't follow what happened here. And that is, when you checked for the symmetry with the y-axis, do you guys remember what you switched? You switched the x value. So maybe you should write yourself a little note. I'm going to switch x to what?
Opposite.
Negative x. Okay. All right. When it's symmetry to the origin, I'm going to switch what? I'm going to switch x to negative x. And then I'm going to switch y to what? Negative y. Okay. So that's what we're going to do. Now, here's the problem. The problem is, the way they talk about it in the book, it isn't quite like this. So what they say in the book is this. If you have a function and you want to know if it's even, all you got to do is switch the x to negative x. So take your function. See, what it is we're in function notation. take your function f of x and switch the x. Well, how do I do that?
F of negative x.
Yeah, just make x negative. Good. Then you work this out. And if this equals your function f of x, you say yes, it's even. That's all you do. So you stick the negative x in, you work it out. If it looks exactly what you started with, it's good. All right, so now let's do this one. Switch x, switch y. So if I switch x, it would be this, f of negative x, right? Now switch the y. How do you switch the y when it comes to function notation?
Put a negative in front of the f of negative x.
Okay, so he says take f of x, which you guys, do you know what that is?
Y.
That's just y. Switch the y to what? Negative. There. That's what you do. So when you're doing these two tests, you do this one for even and this one for odd. And odd goes with the origin. So think of the O. O goes with the O. Okay. Even, I don't have any way to help you there. Even is symmetrical to y. Okay. All right. You ready? Go to your assignments. Let's pick the first one we have to do. Let's see.
50.
No. You guys got to go down to this section, 83 to 90. Determine whether they're even or odd, or neither. So I don't know. What's easy.
I think 84 would be
84. You sure?
Yeah,
Okay.
6%.
Don't trust that person. 84. We'll try it. Okay, ready?
It's h of x
Okay.
equals x cubed minus 5.
X cubed minus 5. Gotcha. And it's h, I guess. So I'll change to h. Okay. Here we go. Check to see if it's even. Check to see if it's odd. If it's even, what are we switching? The x value. So go like this. H of x, write h of negative x. That's all you're switching, and then see if it equals the original function, h of x. If it's even, it will work. Now, this is symmetrical to what, though? This is symmetrical to y. You need to know that. Okay, so here we go. H of negative x. Ready? Put it in. It would read negative x cubed, right? Minus 5 equals h of x. Well, h of x is x cubed minus 5. Okay. Is the left side equal to the right side? Well, you got it simplified. What's negative x times negative x times negative x? Negative x cubed minus 5 equals x cubed minus 5. Is that a yes or a no? Even? Yes? Even? No? No. Not even. Okay, it's not even. All right. Is it odd? Well, you gotta check. Odd, you will do this. Switch the x, switch the y. To switch the y, it looks like this. Okay? So I've already done the left side, haven't I? It's right here. So I know the answer is negative x cubed minus 5. I already did it, so I'm not going to do it again. The right side says take your function h of x, which is x cubed minus 5, and then take the whole function and stick what in front of it? A negative. So go like this, and stick a negative through, or in front. Now, how do you simplify the right side? Distribute the negative 1 through. That's a negative 1, by the way. So go ahead and say negative 1 times this, times that, and say what?
Negative x cubed plus 5.
Equals negative x cubed minus 5. Is it odd or not odd? No, it's not odd. So it's not odd, it's not even, it's what? It's neither. Is it symmetrical to anything? No, it's not symmetrical. The y-axis is not symmetrical to the origin. That's the only two things we check. So you know, it doesn't have to be even and or odd. It can be neither. All right. Are you okay? I thought you guys did okay on this on the quiz the other day. Yes, 2 days ago. I thought you did pretty good work here. Some of you didn't have a clue what to do. You just said yeah, yes, yeah, whatever it was. I don't even know. But you said yes, yes, no, whatever. You didn't show your work very well. But most of you did a good job. Okay. All right. Any questions? You look questionless right now. You okay? I'm done. All right. Then I said in your assignment calendar, let's do problem what? 110 together. So let's do that. The reason is because it's a graph and calculator problem. So grab one if you need one. Otherwise, let's get rolling here. Okay. So open the book and make sure you read with me on this. This one is a little different. What page, man? Okay, here we go. 64 says, this is 110, it says the table shows the temperatures Y in degrees Fahrenheit in a certain city over a 24-hour period. Let X represent the time of day, where X equals 0, E corresponds to 6 a.m. Can you understand that? If X is 0, what time is it?
6 a.m.
Okay, so if X is 2, 8, 4, 10, okay. All right, and then they show you the numbers, the temperatures, all that. Okay, and then it says a model is an equation that represents the data is given by Y equals blah, 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 blah. Okay. Part A says use a graphing calculator to create a scatter plot of the data. Then graph the model in the same viewing window. Let's do it. How do you do it? Do you remember? Okay, here's what it is. It's stat. Go to stat because you're going to enter data and you want to edit. You want to edit the data right here, number 1. So hit enter. Okay. There it is. Now, this is the bad part. The bad part is I have my numbers in from last hour, and you might too, because you're using my calculator. Period 4 didn't wipe out the numbers, did they? No. You should. Okay. How do you wipe out the numbers again?
Clear.
No, well, yeah, but you got to go up into list 1,
Yeah.
and then hit clear, and then down into list 1. They're all gone.
Why did it start at list 4?
It should. Does yours?
Yeah.
Oh, then it's messed up.
Mine started at 3.
Yeah, if it's that way, we got to reset. Why did they do
Yeah.
Mine's messed up too.
Okay, so now this should be good to go. There you go.
I'm totally reading.
Guys, sometimes I get messed up. I do clear the memory on them then.
And then I was trying to
You know what I'm saying? Get second.
Yeah.
You know.
Is that clear?
Yeah, that's good.
Okay.
You want list 1, list 2. Hey guys, list 1, list 2 is the X and Y values. If it starts on L4, somebody messed it up on us. They were punching buttons when they shouldn't have been punching buttons. Okay? Alright. So do you have this? Of course, now you'll enter your X's. 0, 2, 4, 6, 8, and then just keep it going until you get to 20, I think it's 24, isn't it? There. The reason I didn't do my Y's, I'm not starting over my Y's, because I don't have the book in front of me. And if I don't have the book in front of me, it's hard for me to do the Y's. So I kept my Y's alone. But I really think you guys should start from scratch. Actually do it yourself. Because if you don't, a quiz comes and you don't know what you're doing. Okay? All right. Did you get them in? Okay. Now, they want you to graph these points, but they also want you to put the equation in. So go to y equals. And I already have mine in. And I don't see why I should have to clear mine out and start over, because I think it's more important you clear yours out. 0.0626x cubed. minus 1.03 x squared, and so on and so on. It's bigger. Guys, if you're looking up here, look at this. This is my screen. So is this, but I can't read that very well.
I was just using my peripheral vision because it really pushed my limits.
Next up, are we ready?
No.
Okay, when you want this to happen, you got to have your plot on. You see my plot up here, guys? It's highlighted. If it's highlighted, it means the calculator will plot every point. If yours is not on, how do you get it on? You go up there, just go up in the plot, hit enter, and now it should be on. But mine's off because I just took mine off. Go back up, hit enter, it should be back on. It is. Otherwise, it won't plot the points you just put in. Now, there's another problem. You know what the other problem is? The window. Is the window big enough to handle this? Think of your x values. X's went from 0 to 24. So your x value should go 0 to what? 25, 6, 7. Yeah, so I did this. I did my window from 0 to 26. Think of your y values. That's temperature. Your temperatures were in the 30s up to 60 something. I went from 0 up to 80. That's what I did. So you don't have to do my numbers, but if you want to copy my numbers, go ahead. That's what I did. Because if your window's too little, you won't see it. If your window's way too big, you'll see it, but it's going to be microscopic. I'm ready. Are you ready? Big graph. There's my dots. Here comes my equation graph. Looks pretty good. What do you think? Yeah. Kyle? Oh, you typed your equation in wrong, or you typed your points in wrong.
Mine didn't go. Mine didn't even.
You didn't even go?
Oh, mine went right here.
Oh, okay, you didn't quit. It's just that's all you have. You have y, you have x squared. It's x cubed.
You, yeah.
I got it right, so I think.
Upper, insert lines. I'm trying to do this one. You just typed it in. Hey guys, you typed it in wrong. What happened?
I don't know if I could deserve this.
All right, guys. Hey, we got more to do, and you're packing up on me. Don't. Here we go. So what's the answer going to be? You should probably draw a window like this. 0 to 26 is what I did, and 0 to 80. I know the graph went like this, right? That's part A. Part B, does the graph match the data? Yeah, very well. Okay. All right, C talks about where does the function increase? Well, here's where it increases, right here. Right? And right here. This is the increase portion. So where does it increase? You will have to say in interval form from 0 to what?
Right there.
What's right there? You better know your maximum. Your maximum was 6 something. 64, okay. But all you care about when you say when is it increasing are the x values. 0 to 6. Okay?
Yeah.
Alright? I need my quizzes back on that stool. Quizzes back on the stool.
That's your question about what?
Yeah, you can. Hey guys, there's more answers here. I just need to have 6. Alright, okay.
Hey, here you go.
If you need my calculator after school, please come in, let's wrap up this problem. I don't have much time next week to go back to that problem. Yeah. I have 2 quizzes, I need about 20 more.
Well, this, sorry.
Not a thing, not a thing. I didn't call anything wrong, I just,
It was at minus one.
oh, that one, no, check the. Oh, so would you, okay, you do that line, that's all. I need to see the final.
Kevin,
It should say y equals negative 8x plus, which is not all. I know, but Will, the only I can do is when you plug in the line, what's the final?
it is a piece of paper.
Make your answer, right? What's the final?
It looks like. Quiz.
I don't know.
It is June.
Yes.
Yeah.
Yes,
Yes, this is July.
I just looked at it, I didn't saw it.
So you're saying this one I messed up? Yeah, you, okay, you see it.
Yep.
Divided by negative 1.
And then right when I got to the negative x,
Okay, but this wasn't. Yeah, it was mine, so this you had.
Lost is.
so the right x.
You knew to say no because it must not have looked like the original. You know what I'm saying? So when you solve it,
Alright.
okay?
So
That's
one
why.
can fly.
Yes, but no, you can play on the piano, but you can't.
Yeah, it's
You can, right? You can.
Like you're talking about standing.
It's like a twist on it.
I go 3, 4, 5, 6, 7. What's this? This is cold. Whatever. Yeah. Sorry.
One simple thing.
Okay, next.
The power of this bloody ball. Oh, yeah, it's just no.
Well, does she know you're coming?
Well, it's hot.
My thought is could be a waste of
You're not kicking for us.
Yeah,
it's Lucas.
I'm just saying.
Damn, you're on Murph.
No.
Watch what happens.
Yeah, I can miss that. I'm just having like it was like easy.
He always does that. Dude, I've already lost like half of my pencils this year. I think they're on there. They're just like hiding.
Oh, they found me.
Yesterday, I was like,
This was a few
lines were underlined, I was doing 4 years like this year.
Freshman year came, I'm like,
It's like,
that's a real much. Yeah, no, you were.
Do not
do
what's your
Yeah, but I figured out how to compile it, so.
Yeah, just call her. And or not there. Yeah, you can. Okay, so, there. Right. So you can understand. You bet.
yeah. Oh yeah. The church was like 2 group chats, but that's it.
Oh, you're leaving me, is that what you're saying? September 27.
I had the best
Leaving
way
me. I don't see you're gone.
and then come to class. You can watch us. You come and sit outside.
That's back one. I'll show you. I'll give you the calendar.
Will you sign it for me,
Man, the 80s are great. Golden age.
Only bad.
I remember I'm like, I
I
did.
It's an XL.
because the review.
You don't want to eat them. If we're lucky, we might live in Indians.
Okay, dig it out, please. What am I saying? Yeah, get your notes open.
Where are those?